A 3.1 gigabyte AI model. Running entirely inside your browser. No API key. No server. No internet connection after the first load. You type a sentence, and it draws you a diagram. That is not a demo reel. That is what this tool actually does, right now, in a tab. The project is called Prompt-to-Excalidraw, built by a developer named teamchong. It runs Gemma 4e2b, Google's efficient small model, compiled to WebAssembly, directly in the browser using your own CPU and RAM. Excalidraw is the popular open-source tool that produces those clean, hand-drawn style diagrams you've probably seen in architecture docs and engineering blogs. The combination here is wild. You describe a system, a flow, a process, and the model generates the JSON that Excalidraw needs to draw it, all locally. Let's talk about what actually happens when you open it. The first load is the honest part. You are downloading 3.1 gigabytes of model weights into your browser's cache. That takes a few minutes depending on your connection. After that, it's cached. Future loads are instant. Once it's running, you type something like "show me a login flow with OAuth," and within seconds, on a modern laptop, you get a diagram. Boxes, arrows, labels, all in that recognizable Excalidraw sketch style. No round trip to a server. The inference is happening on your machine. Now here's the thing that surprised me most. The diagram quality is actually coherent. This isn't random shapes. The model understands enough about software architecture to produce flows that make logical sense. A login flow has a user, an identity provider, a callback. A deployment pipeline has stages. It's not always perfect, but it's not gibberish either. But here's what it does not do, and this matters. It is slow on average hardware. We're talking 30 to 90 seconds for a response on a mid-range laptop without a GPU. WebAssembly doesn't get GPU acceleration in most browsers yet, so everything runs on CPU. If you have a lower-end machine or less than 8 GB of RAM, you may hit memory limits before the model even loads. The diagram complexity is also capped. Ask it for a simple 3-box flow, great. Ask it for a full microservices architecture with 20 services and cross-cutting concerns, it struggles. The model is efficient by design, which means it trades capability for size. What you gain in browser compatibility you lose in raw reasoning depth. And there's no interactivity loop yet. It generates the diagram, drops it into Excalidraw, and stops. You can't say now add a caching layer and have it update the existing diagram. Each prompt is a fresh generation. For iterative design work, that's a real friction point. What could this realistically become? The bottleneck right now is WebGPU. It's already shipping in Chrome and Edge. Once WebAssembly runtimes fully leverage WebGPU acceleration, inference times on this kind of model could drop from 60 seconds to under 5. That changes the use case entirely. You go from novelty demo to actually useful whiteboarding assistant. There's also a plausible path to offline-first tools for regulated industries. Think hospitals, defense contractors, legal firms, environments where data can't leave the building. A diagramming assistant that never phones home is genuinely valuable in those contexts. The architecture is already there. The performance just needs to catch up. And if someone adds a proper conversation loop where the model can amend an existing diagram rather than regenerating from scratch, the workflow becomes much closer to how people actually think through systems design. So why does this exist? The honest answer is, because it shouldn't work, and someone proved it does. Running a multi-gigabyte language model in a browser tab was, until very recently, considered absurd. The combination of WebAssembly maturity, browser caching improvements, and smaller but capable model architectures like Gemma 4e2b made it possible. This project is a proof of concept, and a very deliberate one. It's not trying to replace cloud AI. It's proving that the assumption that AI inference requires a server is no longer universally true. For developers, this is a template. The stack is open. You could swap Excalidraw for a different output format. You could swap the model. You could build a local-first AI tool for your specific domain and ship it as a static website with zero backend costs. That's the real unlock here. Does it win? Not yet, not for production use. It's too slow on most hardware and too limited in diagram complexity. But it lands squarely in a niche that's about to get a lot bigger: private, offline, browser-native AI. And that niche has serious money and serious demand behind it. Next episode, we're looking at a tool that takes a completely different approach to local AI, running models not in the browser but on the edge, as close to zero latency as you can get. If this one caught your attention, that one will surprise you.